Greetings to the judges and everyone watching. We are Code Currents and we present Ocean Pilot, our solution for the Smart India Hackathon. Our platform is AI-enabled environment designed to solve a critical real-world problem for CMLRE. How can scientists analyze long-term environmental trends when the necessary data is locked away in diverse incompatible files? To answer this, we'll walk you through a specific use case. A CMLRE researcher needs to investigate how ocean temperature has changed over several years in a specific region. The historical data is fragmented across two separate survey files, a standard depth CTDS file and a high resolution CTDO file. Our platform will make integrating and analyzing this data simple and intuitive. Our researcher begins in the data ingestion phase. Their historical dataset is ctds1107.gz, a complex binary format from the World Ocean Database that is typically difficult to work with. With Ocean Pilot, this is seamless. Upon upload, our fast API backend saves the files to a persistent server location and routes it to a specialized parser. This parser uses WODPy, WODPY library and custom flattening function to transform the nested profile data into a clean tabular format. A limited preview is instantly sent to the React frontend, ensuring UI remains fast while giving the researcher immediate confidence in the loaded data.
The user now proceeds to phase 2, column mapping. To prepare this data for future integration, the raw column names must be standardized into a consistent vocabulary like latitude or temperature. Here we introduce the platform's core innovation, the AI assistant. With a single click on Ask AI for suggestions, the user triggers our backend agent. This is a true agentic workflow built with LangChain. Our Gemini model is equipped with a custom-defined Python tool for mapping. A strict prompt forces the agent to call this tool, guaranteeing a reliable structured JSON response. This is pushed back via WebSockets, instantly updating the UI with intelligent recommendations. The user then confirms and these mappings are saved to their secure server-side session. The user now moves to phase 3, pre-processing. The platform immediately presents a comprehensive data quality summary, highlighting that several key nutrient columns like oxygen and phosphate are 100% empty in this particular file. Based on this insight, the user makes an informed decision to remove these empty columns. This triggers a backend data transformation, and the UI is updated with a summary of the action and a preview of the newly cleaned dataset. The user then clicks on Start Analysis phase to finalize this dataset.
Now to build a time series analysis, our researcher now ingests the second historical dataset. They follow the exact same seamless workflow you have just seen. They first upload the file and then they get an instant preview, and then they can use the AI to suggest and confirm the column mappings, and they run it through the same pre-processing stage to create another clean analysis array asset. Now for the critical integration step, the user navigates to the merge datasets view. Here they can see both of the clean datasets from their session. They select both the files to create a single unified time series dataset. To perform the right temporal analysis, the datasets must be joined on a common time axis. As you can see, based on the standardized roles we created earlier, the user can easily identify and select the date column from both the datasets as a key for the join. The user generates a preview of this newly unified dataset, which provides a clear overview of the merge, including the final dimensions and how columns with conflicting names were handled before the user confirms the action. This creates a new rich dataset in the workflow history that was impossible to create before.
Now, with a unified dataset spanning multiple historical surveys, our researcher can finally answer their original research question. They take this new integrated dataset into the analysis phase. They can now ask the AI assistant the critical question: show me the line chart with date on x axis and temperature on y axis. The agent's generate analysis and plot tool is triggered. But our platform doesn't just show a plot. The statistical summary from the analysis is fed back to the agent. As you can see in the chat panel, the agent provides a detailed interpretation of the results. It describes the overall temperature trend over time, notes the seasonal variations visible in the data, and assesses the oceanographic significance. This is the core of our solution. We have transformed a complex multi-file analysis that would typically take a researcher hours or days into a simple question and a clear decision-ready answer.
For expert users who need to perform deep manual exploration, we have the Data Playground. This feature opens any dataset, raw, pre-processed or merged, in a powerful spreadsheet-like interface. To ensure the UI is always fast, all filtering, sorting and searching operations are handled on the server side. The user can build complex queries and our backend processes the full dataset to return only the specific slice of data needed. In conclusion, Ocean Pilot delivers a complete end-to-end workflow that directly solves CMLRE's core challenge of data integration. By leveraging a sophisticated AI agent at every step, we transform a difficult manual process into an intelligent and interactive scientific discovery environment. Our platform is not just a tool, it is a scalable, cloud ready foundation for the future of marine science in India. Thank you.